Well, hello everybody, and welcome to Tuesday. We're continuing with functions and modeling and predicting change. And what we had begun looking at the last week was systems of equations. And when we're looking at what a systems of equation is, we use it to answer the question, how can I model two or more events that share a common solution? And the answer to that is to use a system of equations, which occurs when two events are happening simultaneously or together at one time. And the solution to a systems of equations is an ordered pair that makes both equations true. Okay, so that's what we had learned last week. And we had learned last week that we can solve systems of equations by graphing. And when we solve systems of equations by graphing, it produces one solution, and it gives us the opportunity to model and find an answer to two events happening at the same time, like we did with one hot air balloon going higher into the air, and another hot air balloon already in the air coming down to a lower altitude. So, while graphing is a good way to solve most systems of equations, it's not the only way. It may not always be the most practical way. So if we look at this example today, we have two systems of equations, 4x plus 7y equals 19, which is a linear equation in standard form. And then we have y equals x plus 9, which is a linear equation in slope-intercept form. And in this example, we want to find the ordered pair solution for the following systems of equations algebraically. So there are two ways to find a solution to a system of equations algebraically. The way we're going to learn today is by using substitution. So here are 3 steps for solving by substitution. If you need to, go ahead and pause the video now and write these down somewhere because you'll need them as we go through our practice problems. The first thing we're going to do is substitute the expression into the other equation, solve the equation for the other variable, and then substitute your answer into one of the original equations and solve for the other value. So if you need to, I'm going to pause the video on my end, and you go ahead and pause as well and write these down. All right, so we're back. So let's go ahead and go back to our previous practice problem that we had up, which was the 4x plus 7y equals 19 and y equals x plus 9. And we will follow these 3 steps to solve this system of equations. All right, so I have 4x plus 7y equals 19. And then I have y equals x plus 9. All right, so the first step is to substitute the expression into the other equation. Well, right here I have y equals x plus 9. So this is the expression that I am going to substitute into the equation because this x plus 9 is the value of y. It's not any different if we said y equals 3. We would substitute 3 every place we see a y. But here we're saying that y equals an expression. So we're simply going to take this expression and substitute it every place that y occurs. So we're going to have 4x plus 7 times x plus 9 equals 19. And then we're simply going to solve the equation. So we distribute here. So now I have 11x plus 63 equals 19. I'll subtract 63 from both sides. And I have 11x equals a negative 44. I divide both sides by 11, and I get x equals negative 4. So there is the second step of solving the equation for the other variable. So I substituted the value of y and then solved for x. Now the third step is to substitute your answer into one of the original equations and solve for the other variable. Well, I already have an equation that defines the value of y, which is x plus 9. So I will simply take that equation, substitute the value of x into this equation, and I get y equals 5. So my ordered pair solution for this systems of equation is negative 4, 5. So whenever you write the answers to these types of systems of equations, you always want to write it as an ordered pair, because this is the ordered pair that we could substitute back into both equations, and that will make both equations true statements. All right, so if we go to then our next example, which is 2y minus 4x equals 14, and y equals 6x plus 11. So let's go ahead and write those down. We're going to have 2y minus 4x equals 14, and y equals 6x plus 11. Okay, so the first step is to substitute the expression into the other equation. So here's the expression. This is what y equals, so I'm going to substitute that into here and write 2 times 6x plus 11 minus 4x equals 14. And then step number 2 is to solve the equation for the other variable. So I'm going to solve this equation for x. So I'll combine my like terms. 12x minus 4x is going to give me 8x. So I have x equals negative 1. So my final step is to substitute your answer into one of the original equations and solve for the other value. Well, again, I have an equation that already tells me, or is defined in terms of x, which is y equals 6x plus 11. So I will simply substitute the negative 1 in for x. So for this systems of equations, my ordered pair solution is negative 1, 5. So that means on the coordinate plane, if I were to have changed the other one into slope-intercept form and graphed both of them, they would intersect at the point negative 1, 5. And again, this is the ordered pair solution that, if placed inside both equations, would make them a true statement. All right, so then let's go to our final example, which is going to be the 3x minus 2y equals negative 3, and x equals 2y minus 1. All right, so this one isn't any different. Just instead of having y equals, we now have x equals. So we're going to do the same thing, is take this expression and substitute it every place we see an x. So that's going to give me 3 times 2y minus 1 minus 2y equals a negative 3. And then I'm just simply going to solve this equation for the variable. And when I combine my like terms, 6y and the negative 2y, I get 4y minus 3. So negative 3 plus 3 equals 0. And then I divide both sides by 4. 0 divided by 4 is 0, so y equals 0. Okay. So that's my first 2 steps. My third step would then be to substitute your answer into one of the original equations and solve for the other variable. So I already have an equation that defines my other variable, x equals 2y minus 1. So x equals 2 times 0 minus 1. 0 minus 1, x equals a negative 1. So my ordered pair solution for this systems of equations is going to be negative 1, 0, which means that is the ordered pair that, if substituted into both of these equations, would make both equations true. All right, so what you've got for today is there's 5 more slides for you to do. I'm only giving you 5 problems today because this is introduction day, and plus we're going to be doing more of these tomorrow and on Thursday when we get to the word problems. So you will get plenty of practice doing this, and we'll get very proficient at it, which is why we'll start with a few today. So on your slide deck here, make sure you go through all of the slides that have problems on them. You should do 5 problems today and upload a copy of your work to Canvas. All right, so have a great day, everybody. I will be on Google Meet during my normal hours if you require assistance, and we'll have something else to do tomorrow. Have a great day.